Hello friends, in System Design Interview Toolkit Part 1, we are going to understand about a pattern for representing the large numbers. This tool is very handy while answering interview questions or doing capacity planning in your actual design. We can leverage this tool for doing network, storage, or TPS estimation. Many times we get confused while dealing with large numbers and how to read or write them quickly. Or we could have faced a challenge while converting many bytes to larger representation like MB, GB, terabyte, etc. or vice versa. One important tip I would like to share, you should always round off all the numbers in the form of tens. It makes life easy while doing the calculation. For example, in reality 1 kilobyte is 1024 byte, but for calculation purpose we should always treat it as 1000. So in the numeral system, every next large numeral is 1,000 times from the previous. So this is a key here to remember the numeral system. And if we just see here, we are having 1. Let me just highlight this. We are having base unit which is 1, which is having no zeros, right? There is no zeros. And the very next numeral system is 1000, which is again 1,000 times, or it is having 3 additional zeros from the previous system. So it is 10 to the power 3. Now go to the very next number, large number, which is million. In the million, you will find additional trailing 3 zeros from its previous number system, right? Here you will get 10 to the power 6 or 6 zeros in the million. Similarly for billion, if you see the pattern, we are adding additional 3 zeros, trailing zeros. So in the million, if we will add additional 3 zeros, it will become billion. Similarly in the billion, if we will add additional 3 zeros, it will become trillion. And then it goes like that. We can get the peta also. Same calculation goes with the byte calculation as well. For every next large representation of bytes is 1,000 times from the previous representation. If we take 1 as our base number, so 1 byte is represented like this. There is no zeros, right? It's single byte. Similarly, if we take 1 kilobyte, that if we want to write in a number of bytes, there will be 10 to the power 3 bytes, or we can represent it as like 1 trailing with 3 zeros. Similarly, if we talk about 1 MB, MB will have additional 3 zeros from its previous system, which is like KB. So in KB, if we will add additional 3 zeros, it will become a million bytes, right? Same as like number system. 10 to the power 6 is 1 million. So it's a million bytes, and it is a representation of 1 million byte, 1 megabyte. So you can remember it like that as well. 1 million bytes equal to 1 megabyte. Same logic goes for GB. If we wanted to write how many bytes are there in 1 GB, we can do it like that. In the 1 MB or in 1 million, if we will add additional 3 zeros, it becomes billion bytes. So in 1 GB, there are 1 billion bytes present. And if you will see the pattern, every next representation is having 3 additional zeros, right? So similarly, you can do the calculation for trillion bytes as well and petabytes as well. So I'll just give you few examples so that you will be much more clear how to use this information. So let me quickly just take this example. So we wanted to calculate the storage capacity required for a system having 1 million user requests per day, and each request payload is 1 kilobyte, right? So here we are having 1 million request, 1 million, and we know 1 million is 10 to the power 6, correct? And each payload request is 1 kb. So if we multiply it by 1 kb, 1 kb which is equivalent to, you can say, 10 to the power 3, right? So how you are going to get the calculation? 10 to the power 6 into 10 to the power 3, which is equal to 10 to the power 9. And 10 to the power 9 we know always is a billion, right? So we will require 1 billion bytes of storage for storing data for 1 million user of request, where each request payload is 1 kilobyte, right? So I am just going to write it here, 1 billion bytes. And you know pretty well, if we wanted to convert 1 billion bytes to a higher number, then we can represent it like 1 GB, right? Because 1 million equal to 1 MB, that is very easy to remember. So in 1 million, if we add additional 3 zeros, it becomes a 1 GB, correct? So we will require 1 GB of space. Similarly, if we wanted to use this space for a 1 year, right? We wanted to store this data for 1 year. So how much space will be required? In that case, we can multiply 365 days with this 1 GB. We will get 365 GB, right? So 365 GB storage is needed to accommodate this much request. So let me take one more example where we can try to write some numbers and try to see if we are able to generate its numeral or not. So for example, let's say I will just randomly take some number. So if for this number, if I have to come up with a numeral system, then what I am going to do is I am just going to create a pair of 3 digits. Then this is again a 3 digit. Then this is again a 3 digit. This is, I know this is 1000, then this is million, then this is billion. Then easily I can say, okay, this is 10 billion of request or 10 billion of bytes or whatever it is. As I mentioned, we should most of the time we should just ignore these lower values, and we should consider it as 0. So it is 10 billion, right? And that's how you can calculate it. So I am giving you some example, and try to do those examples by your own, and write the answers in the comment section. What will be the value of those examples, right? So for example, let me give you 3 6 9 5 1 2 3 0 6 1 2. So this is one of the number for which you can try to find how we can represent it in numeral system, and then comment it in the comment section. And you can tell what is your favorite way of learning or remembering these big numbers, large numbers, which help you in the interviews. So other candidates can also leverage that if they like it. Thank you.